All right, this is Chapter 9, Section 1, Ratios and Proportions for Integrated Math 2 or IM2. I am reusing some of these topics from another video, so the problem numbers may not match up perfectly, but they will be in order. This is what it will look like when you click on any assignment, with the exception of two things. So first thing is you will see a due date here. I don't see that on the teacher preview for whatever reason, but you will see it on your screen. Attempts, you will see one of unlimited attempts, or whichever attempt you're on. This might not be your first time in here. Unlimited means I can come in here and try this assignment as many times as I would like. I need to submit it every time I come in. I'll talk about that in a minute. This particular assignment has 8 questions on it. They'll have anywhere from 1 to 10 questions. So just, be aware of that, the number of questions there. Grading policy is best score, so whichever attempt is your best one is the one you get to keep. And partial credit is enabled. So if I answer one of 8 questions, I get credit for the 1 question. So this is where we get into the submitting button. So please remember that you always want to finish or submit your work. So once I click the start button, this is the second thing that will be slightly different on your screen. Down in the bottom right corner, you should see Submit Assignment button. I don't see that on the teacher preview because I'm not actually going to submit this button or this assignment, but you should see it here. So as soon as you start this assignment, you need to click that button if you're done and you want to leave. So I'm not saying click it right now if you're working on it, but as soon as you're ready to leave, you need to click that button. So whether or not you've answered any questions, you've only answered one, or you've answered all of them, you're going to click Submit Assignment. Number 1, that shows us that you are in here working. It shows us what you've completed and at what percentage you've completed it. The other thing is that if you don't click the Submit Assignment button and you just leave the screen by closing it or going back to home, it's going to lock you out of every other assignment. You won't be able to do topics, quizzes, homeworks, or tests, other homework assignments. None of it will open until you come back to this assignment. So that's definitely kind of a bother if you do that. So make sure you click that Submit Assignment button. On the right side here, we have explanation, example, and message. You might also see calculator from time to time. So explanation will literally give you a solution to the problem we are looking at right now. So it's not going to give you the answer and then have you come type it in. You're going to lose that question attempt. So it will give you a red X here, and you'll have to submit the assignment and come back and try another one. And you can, go through and do all your other questions first and then come back and try this one if you want. But you can also click example, and this will give you just a general example of this type of problem. So here we can see write a ratio as a fraction in simplest form with whole numbers in the numerator and the denominator. So that a ratio is a fraction, and we're comparing two numbers, 16 yards to 56 yards. So we can see that's happening here. 16 yards to 56 yards. We just have a fraction form now. And then we also have to simplify it. It's said in simplest form. So we need to make sure we simplify it all the way down. Otherwise, it's going to mark us wrong. It will not just let you do 16 over 56 like it has here. We have to go all the way down so that we are simplifying down to 2 and 7. If I want another example, I can click on example again. It'll give me a brand new one. And I can message my teacher from here as well, which it'll attach this question to the message. So now we know exactly where to come help you. Okay, let's go ahead and get started on this guy. All right, so for this first question, we are going to set up a ratio, just comparing these numbers. So it's a simplifying ratio for a real world situation, I believe. Trying to find the title for it real quick, darn it. Solving a real world problem on proportions using a single unit or a unit rate. So there are 6 roses and 9 daisies in a vase. What is the ratio of all flowers in the vase to roses? So we just need to kind of pay attention to what it's asking us. So all flowers in a vase to roses. So all flowers is 6 plus 9, which is 15, to roses, which is going to be just the number of roses. So it's going to be 15 to 6. I'm trying to remember if they might have us reduce here. So I'm going to try it not reduced, and then I'm going to go back and see if they want us to reduce it, because I don't particularly remember if they have us reduce it or not. And okay, So we have, what is the ratio of all flowers to daisies? So it's going to be 15 again, all flowers, to daisies, which is 9. So if they ever reduce it, they can all definitely divide by 3. So let's see if it takes it this way or if it makes us reduce it real quick. It did. So I think they would have also taken it reduced. I'm going to take a look really quick just to see. Oh, these ones couldn't have reduced. Let's see if I click on it again. Well, they keep giving us examples that don't reduce here. These ones would have reduced and they didn't reduce it. So unless I actually tried another one that could reduce and, just tested it out. But that's, the nice thing about this one. If you had reduced it, divided everything by 3, then, and it said, that's incorrect, you can go back and go, okay, maybe I shouldn't have been reducing because it didn't tell me to reduce. All right, so let's go ahead and try the next one. So we have write the ratios of fraction in simplest form with whole numbers in the numerator and denominator. So they do not want any decimals here. Okay. So if we have 24 years to 56 years, we're going to do just like they did on that example. 24 years to 56 years. So 2 is another way of comparing with a fraction. So that means that we need that, that fraction bar there. Years are going to cancel off year over year, and we're just going to compare the numbers now. So 24 over 56. Well, we want to simplify this as best we can. So we can think if you can identify the greatest common factor, that's definitely helpful. But you can also just say they're even. I can divide by 2. And you can do that multiple times. So in this case, I believe the greatest common factor will be 8. If I'm thinking of that correctly. They both divide by 8 here. So that's helpful. I could do 2s, I could do 4s. I just might have to do the division more than once to get all the way to the end. Because if I do divide by 2, well, that's not going to be done. I'm going to have to divide by 2 again. And that still won't be done. I'm going to have to divide both by 2 again. So if I know the greatest common factor, I can just divide once. So 24 divided by 8 is 3. And 56 divided by 8 is 7. So that was definitely the greatest common factor because 3 and 7 are both prime and they cannot divide into each other. So 3, 7. And if you notice, if they wanted years on here, it would have either already been here or it would have been a clickable button. So that's how I know they want us to cancel those out since there's year on the top and year on the bottom. All right, next one. Charmaine made $247 for 13 hours of work. At the same rate, how much would she make for 9 hours of work? All right, so we can set up a little proportion here. So they're kind of jumping straight into proportions. So a ratio is just what we were just doing. It's just two numbers being compared in fraction form. So that was a ratio. When we have a proportion, that means we're going to have two ratios equal to each other. So we have a fraction equaling a fraction. So whenever I'm given a problem like this, I can start to set it up where I have hours over pay, or pay over hours. I can do it either way I want to there. It would probably make a little more sense actually to do pay over hours. It really won't change the problem as long as I write them correctly. So, and when I write the next one, I want to do the same thing, pay over hours, like this. So then I need to make sure that the two fractions have the same units on top and bottom. So now they told us she gets $247 for 13 hours of work. So 247 to 13 hours equals, at the same rate, how much would she make for 9 hours? So I don't know how much she would make yet. It's saying how much, but I do know the number of hours I'm asking about. So it'd be 9 hours. So now I have my proportion set up, and this is a P. I know that kind of looks like a backwards 9, but it's a P. Once we have a proportion set up, what we can do is we can cross multiply. So I can go like this, 247 times 9. So 247 times 9. And they did give us a calculator on this one, so I'll come over there in just a minute. Equals, and then we're going to cross multiply the other way here, like this. 13 times P is just 13P. So I do want to do my calculation here, 247 times, why isn't it typing it in? 247 times 9. All right. So that gives me a pretty decent number there, 2,223. And that's going to equal, I'm being all color-coded here, 13p. All right. So now what I want to do is, just like we've done on previous ones where we're solving equations, I want to know what just p equals. So I'm going to divide both sides by 13 so that it cancels out on this side. So I'm going to come to my calculator, I'm going to go divide by 13, and that equals 171. Equals P. So this tells me she's going to make $171 if she works for 9 hours. So I'm not working out the hourly pay on here. We set this up so that when I get to the end, I know how much she made for the 9 hours. You could have also done this a slightly different way. We could have said 247 divided by 13. And that would have gotten us 19. What that tells me, if I divide 247 by 13, that tells me she makes $19 an hour. If she makes $19 for every hour, and she works for 9 hours, I can say $19 times 9, and that will also bring me to the 171. So it's not always as easy to do it that way, but you can do it that way if you want, bringing it down basically to a unit price. So instead of looking at 13 hours, I can look at 1 hour of work. So she gets 19 hours for every 1 hour. If she works 9 hours, we just multiply by 9. So it's just 2 ways to do the same problem. Oops. Help if I'm typing that in right. There we go. Okay, next. All right, so now we do have a proportion. Sorry, I'm just resetting my board here. So we have W over 8 equals 3 over 12. So once we have a proportion, a fraction equaling a fraction, we should be doing the cross multiplication. So W times 12 equals, and I'm going to only color code this first step, and then I'm going to move to a different, just like one solid color here. 8 times 3. So you can just see I'm circling from top to bottom, left to right, and then top to bottom on the other one. All right, so I'm going to go back to my orange for whatever reason. So W times 12 is just 12W equals 8 times 3, which is 24. All right, so now I want to solve this. I don't want to know what 12W is, just W. So I'm going to divide by 12 on both sides. Since I'm multiplying by 12, they cancel out. 12 divided by 12 becomes 1. I don't have to write 1W, just W. 24 divided by 12 is 2. If you're having trouble with some of your math facts, if that's not super quick for you, I would definitely suggest going on quick tables on here. That's a activity we already have loaded on here. We're just not assigning it this year, but it's still available for you to practice those math facts and get a little faster at that. All right, next. All right, so this is just like the last one. They just have slightly different titles. One says basic and the other one doesn't, but they're pretty much the exact same idea. The only difference I can see is they've moved the variable from one side to the other, which doesn't really make any difference at all. We still have two ratios equaling each other to have a proportion, and we're going to do some cross multiplication here. We're going to have 3 times 6, and that'll give us 18, and that's going to equal 9 times v, which is just 9v. And then we're going to solve that by doing our simple division here. 18 divided by 9 is 2, 9 divided by 9 is 1, and v gets left alone. So again, I could have also said, I could have looked here, and decided, what did I do? Well, it's not quite as easy because we have 2 over, so this would reduce down into 1/3 if we were actually going to reduce it. And then that might be a little bit easier because if it's 1/3, then I can say, well, what did I multiply by to get 6? I multiplied by 2. What did I multiply by the bottom? I multiplied by the top. So it's not as easy to convert 9 into 6, but to convert 3 into 6 it is. So this is not reduced all the way, that ratio, so it makes it a little bit more difficult to just kind of visually look at it and say, oh, well, I know what to multiply by here. 2.5 equals y, because these guys would cancel out. All right, next one. So now we're getting a little bit more complicated here because they're giving us a binomial. That's what this is. When we have two pieces, we call it a binomial instead of a monomial, which is one piece. So that's kind of some root words there. Mono means one, bi means two. If it's a trinomial, well, tri means three, like tricycle, right? And you can even think of bicycle for binomial, two wheels, two numbers. So we're still going to cross multiply. It's still a fraction equaling a fraction. I'm going to go like this. The mistake I see made here is that we just multiply 5 and 10 because they're the closest. What this means is it's 10 times the entire top. So I need to put parentheses in. And then that's going to equal the other cross multiplication here, which is 4 times 3. So I just did that one in my head with 12. So now before I can start getting v by itself, I'm going to need to distribute this 10. So it's going to be 10 times v, which is 10v. 10 times negative 5, which is negative 50. That's going to equal 12 because nothing happened to the 12 on that side. All right, now I can start to solve. So this is going back. We're kind of at the point where we're at a two-step equation now, or we have 2 steps left. So I'm looking what's being added or subtracted to the variable. Well, 50 is being subtracted, so I'm going to add 50 to both sides. And then we have 10v drops down, 50 minus 50 cancels. That's going to equal 62. So now what's being multiplied or divided by the variable or to the variable? So we have 10. I'm going to divide because it's being multiplied. So I'm dividing by 10. 10 divided by 10 cancels, and we have v equals, it doesn't tell me to do any rounding here. But if I divide, and I'm going to check this right now, I would get 6.2. So it may very well accept 6.2. I'm going to try it out just to see what it does. If it doesn't, then we could just reduce this, right? Because they both divide by at least 2. So I could say 31 over 5, because 62 divided by 2 is 31. 10 divided by 2 is 5. And then they also have this mixed number piece here. So I'm assuming they want us to go even a step further and turn it into a mixed number. Well, how many 5s can I pull out of 31? Well, that would be 6, right? Because that would get me to 30. And then I would have 1/5 left over. So 3 answers that all mean the same thing. But it all depends on what they let us type in here. So let's see, will they let us type in 6.2? They did. So they let me put in the decimal there. Be careful, though, if you have a rounding issue, don't do any rounding on this one. So if you get a weird decimal that's not terminating, I would not use the decimal form. I would use the fraction form. So just be very, very careful about that if it doesn't tell you to round anything. All right. So we're going to go ahead and keep moving here. Negative 24 over x minus 5 equals negative 9 over x. So now they're just giving us a lot more negatives. And we have x twice in the equation. So they're throwing a few things at us. All right, so we're still going to cross multiply. That's the first thing we do. As soon as we see fraction equaling a fraction, we cross multiply. So negative 24 times x, well, that's just negative 24x, equals, and we have x minus 5 times negative 9. Remember, it's not just 5 times 9, or negative 9. It's this negative 9 is times the whole thing. And it wouldn't have mattered either if I wrote it this way. If I said x minus 5 times negative 9, I would put it in parentheses just so you know that you're not subtracting the 9. Just be a little careful about that notation. But you can put it on the end or you can put it on the beginning. Totally up to you, kind of preference-wise there. We do need to reduce this as far as, or not reduce, but simplify. So negative 9 times x, we get negative 9x. And negative 9 times negative 5, well, that's going to give me positive. 2 negatives make a positive, and 45. Okay, so now we're going back, quite a few sections there where we had variables on both sides of our equation, and we need to bring them together. I do tend to like to make them positive, but I'm not going to move this 24 simply because it's already by itself on the left side. So I'm going to go ahead and bring the 9 over to the negative 24. Just so that it gives me one less step to worry about. So I like to have those positives. If you watched those videos before, that was the comment I made. But it's not necessarily always the best method. So now we have negative 24 plus 9. They're opposites. We need to subtract. I have more negative because 24 is bigger, so it's going to be negative 15x equals 9 minus 9 cancels. And then we have 45 here because it comes down. All right, last step here, I'm multiplying by negative 15, so I'm going to divide by 15 on both sides. 15 divided by 15 cancels out, and I have x equals 45 divided by negative 15. Well, I know it's going to be negative because it's a positive divided by a negative. And then 45 divided by 15 is 3. Again, if you're having trouble with math facts, I'm going to point you back over toward the quick tables. That would definitely be something I would start playing with. And it's literally just multiplication practice. Addition, subtraction, multiplication, and division. We have one for each of them. And you can practice all of your math facts there. Very nice way to kind of increase those skills so that it makes some of these steps a little easier. All right, 2 more of these. All right, so we're just going to keep on doing the same. Oop, I'll find my pen on. Same idea. So we have 10x minus 2 equals negative 8 over x plus 2. Now we have 2 binomials in this one. Oh, pen, stop doing that. Sometimes it gets a little stuck there. All right, so we're going to do the same thing. We're going to go cross multiply. So 10 times x plus 7. Remember, this means we're going to distribute this 10. So I'm just going to kind of... Stop doing that, pen. Plus 70, because I have 10x and 70. And then I'm going to go equals... And I'm going to cross multiply the other way here. So it's going to be 8 times x minus 2. And I'm going to distribute that 8. So I'm going to have 8x minus 16. So now I can start to solve this. So my first task is to bring these variables together. I like to do it in a way that makes them stay positive. So 10 minus 8 stays positive 2 plus 70 equals negative 16. 8 minus 8, or 8x minus 8x cancels out. I'm going to subtract 70 for both sides because now I'm trying to get x by itself. So 2x, 70 minus 70 cancels. And I have 6 and 8. They're both negative, so I add and keep the negative sign. And then I'm going to divide both sides by 2. X equals negative 43. So negative 43. Check. Oh, dang it. I forgot the negative because I crossed it off when I circled the red. That should have been negative. So it should be negative and positive 16. So that means I should be adding the 8, which would get me 18. Poop, that changes a bunch. And then that 16 is positive 16. So that's positive there. So this is going to be, I'm going to subtract these. So instead of 86, I'm going to end up with, I'm going to switch the spots real quick just so I can picture that a little bit better. So that's 4 and 5. It's 54. 54 divided by 18 is going to be, let's see, 18, that gets me 36. Another 18, I believe, is going to get me 54. Yep. So that's going to get me 3. So I was way off. It is still going to be negative, though. Negative 3. So sorry, I know that was all messy looking, but that was an oops. One little oops. That I just crossed off the negative sign there and didn't bring it down. And see how many mistakes it kind of trickled down into the equation. So definitely a big deal about paying attention, making sure that you're writing that question down not only correctly, but also paying attention after you've written it down, because that does matter. All right. So let's keep moving here. All right, so this one, It's still the same idea. They're just being a little bit more tricky looking with it. Because remember, the 6 has a 1 under it, so technically I could still do this cross multiplication as far as, solving it this way. But I can just say I'm going to multiply both sides by y, because I want to get it out from underneath the denominator there. And y divided by y cancels. So I have 48 equals 6y, and then I can divide by 6. So that would give me 8 equals y. Now if I were to do the cross multiplication here, like this, equals 6, and I put the 1 underneath it, and I said 48 times 1 will that get me 48. 6 times y got me 6y. Do you notice how it looks exactly like this one here? So either method you choose will still work. It's not really going to change. If you want to do that cross multiplication, you're welcome to it. Uh-oh. Did my guy freeze here? Oh. All right, I'm just going to reload the preview and we'll just go to number 9 here. Okay, so number 9 looks pretty much the same as number 8 there. I know when we did this one in class, let's see, is number 8 still the same? Number 9 in class had negatives on it. Let's see. Oh, it's not going to give me another one until I try it out here. So I have 8v equals 6. Remember, I could go 1. This would be 8. 8 times 1 is 8. V times 6 is 6v. So I could use that cross multiplication idea, do it that way, and then go divide by 6. And so this one, I'm going to have 8 divided by 6, which I'm going to have to reduce because it wants us to simplify as much as possible. And then v is by itself now, but I can divide by 2. I can divide by 2. So I have 4 thirds. So 4 thirds, check. If you have negatives, just make sure you're paying attention and applying the negatives properly. All right, last one here. So we have a machine produces 374 bolts in 33 minutes. At the same rate, how many minutes would it take to produce 272 bolts? So I kind of want to know how many it's going to produce per minute, but I don't really need to reduce it down to the unit rate. I can say bolts per minute. This is my ratio that I'm going to set equal to the other side. So this was bolts and this was minutes. I want to do the same thing on this ratio when I set the proportion. So I have bolts and I'm going to go M for minutes. So I've already set up a proportion. All I have to do is solve this guy by using cross multiplication. So I have 374m equals, I guess I'm kind of doing this a little backwards, and they gave me a calculator here, so I'm going to go ahead and use this guy. 272 times 33, so that's 8,976. And to solve this, I'm going to divide both sides by 374, because that's the only number that's left by my m here. 374 divided by 374 cancels. So I'm going to go divided by 374. And I get 24. So it would take 24 minutes to produce 272 bolts. Alrighty, so that was section 1. I will see you in section 2.